Welcome to another physics class. For some weeks, we will be looking at different types of motion. And the last one we treated is simple harmonic motion. So today, we want to look at causes of motion, which is force. But before we continue, if you are not just joining us on this channel, you have the better understanding of all the topics we have been treating. Please try to like, share, and subscribe so that as we are taking the topic one after the other, you too will be following us. Now for today, causes of motion. And the causes of motion is force. The first thing we are going to look at is definition of force. What is force? Force can be defined as that which change body position of rest or uniform motion in a straight line with time. That is, a body can be at rest. Force can change its position. Or if it is on a straight line, uniform motion, force will change the state of motion with time. Let's write. Force is that which changes body of rest or uniform motion. Uniform straight line with time. See, that entity that changes the body position of rest or uniform motion in a straight line with time is what we call force. Now, let's add more fact about force. Force is a vector quantity. Force is a vector quantity. When you say vector quantity, quantity that have both magnitude and follow a specific direction. That's what I mean by vector quantity. Another point about force. Force is a derived quantity. Force is a derived quantity. The unit of force, are 1. First common unit is Newton, denoted by capital N. And since we said force is a derived quantity, force can also be second unit, kilogram, meter per second square. That is kilogram meter per second square. And this is the basic unit. Basic unit of force. Don't forget, when we treated derived quantity, we made mention of derived unit and basic unit. And when you say basic unit, any unit that contains the fundamental unit of that quantity is the basic unit. For instance, we said kilogram meter per second square is the basic unit. Here now, kilogram is the unit of mass, meter is the unit of length, and second is the unit of time. You can now say that all those mentioned quantity now are fundamental. So that is why kgm per square is the basic unit of force. Force in terms of magnitude now. Force term of magnitude. To divide force in terms of magnitude, we are going to have 1. Horizontal force. Horizontal force. And this horizontal force, the magnitude of this one is F is equal to ma, where this m is the mass of the object, where m is equal to mass of the object or body. A there is the linear acceleration. And since this A is linear acceleration, that is why we say this one is horizontal force, where F is horizontal force. That is the first one when we want to determine force in terms of magnitude. And the horizontal force can be measured. Horizontal. This one is measured with an instrument called dynamometer. Dynamometer. That is the instrument we use to measure horizontal force. We use dynamometer to measure horizontal force. It measures horizontal force. Number 2, force in terms of magnitude. We have force of gravity. Force of gravity. Or you call it vertical force. Or in another word, you call it weight. Weight. And for this one, the magnitude is given as F is equal to mg, where m is the same as we have defined above, but g is what? Where g is equal to acceleration due to gravity. That's why we call it force of gravity. So because this one, horizontal force, acceleration due to gravity have no effect on it. But when you say vertical force or force of gravity, G have effect on it, and the magnitude is given as F is equal to mg. Now, what are the possible instruments to measure this force of gravity? As we said, for horizontal force, we use dynamometer. Then, now say instrument to measure force of gravity or weight. 1, we have spring balance. Spring balance to measure force of gravity. 2, we have gravimeter. Then we have gravitational accelerometer. These are the possible 3 instruments that we can use to measure force of gravity or vertical force or weight. The first one, spring balance. 2, gravimeter. and 3, gravitational accelerometer. Now, the next thing we are going to look at under force is effect of force. Effect of force on any material. Effect of force. That is, when you apply force to the body or any material, what will be the effect of the force on that material? 1, it causes deformation. Deformation. That is, when you apply force to any object, it will deform that object. 2, it changes the position of an object from rest. If an object is at rest before and you apply force to it, definitely the position of that object will change from rest. 3, it changes the speed of velocity of an object. It changes the speed or the velocity of an object. So when the force is applied to an object, definitely it will change the speed or velocity of such object. Number 4 effect is it changes the direction of an object. Definitely when an object is being applied with force, then the direction of such subject will be changed. These are the major effects of force on an object. It can have many effects, but these are the 4 major ones that we can have. The next thing we are going to look at is types of force. Types of force. Majorly, there are 2 major types of force. There are 2 major types of force. 1, we have contact force. Contact force. Then 2, no contact. No contact. No contact, or you call it field force. These are the 2 major types of force. As I said, these are the 2 major types of force that we have. Contact force, and mind you, the contact force is also known as mechanical force. So it can be called contact force or mechanical force. While the second one, non-contact force, can also be called field force. Now, let's take them one after the other. The first one, contact force or mechanical force. Contact or mechanical. When you say contact force, from the word contact, this is the first experience when 2 solid objects are in contact. That is, the 2 solid objects must be in contact before this force can be experienced. Right. Force experience when 2 solid objects, 2 solid, it must be solid objects, 2 solid objects are in contact. That's what made by contact or mechanical force. We have various examples of contact force. Let's label it A. We have push force. Push force. And when you say push force experience when two solid objects are in contact facing the same direction. That is, the two solid objects involved under push must face the same direction. Examples of this one is a boy pushing wheelbarrow. Both the wheelbarrow and the boy will face the same direction. That is push force. The second one, this is B, is pull force. This is just the opposite of push. The two solid objects involved in this one will face opposite direction. One will face this direction at the same time. The other also will face this direction. So they will be pulling each other. That is pull force experience when two solid objects are in contact facing opposite direction. That is pull force. That is force experience when two solid objects are in contact facing opposite direction. That is the pull force. That is, two solid objects involved in this one will face opposite direction. A typical example is two boys pulling each other, one to the right, the other one to the left, or to the front or backward. So their forces will be opposite to each other. So that is pull force. Now, let's take this one and C. And the C, which is number 3, is tension force. This one is force on extended rope or cord or string. Force on extended rope or cord or string is what tension force. D, which will be number 4, normal reaction force. This one is the force experience when two solid objects, or is the upward perpendicular force that press two solid surfaces together. Upward perpendicular force that press two solid surfaces together. Upward. That is, the direction of this one is upward. Upward perpendicular force that press two solid surfaces together. Upward perpendicular force, that is, when you have two surfaces, like when you place a wooden block on an horizontal surface like this, the force produced by this surface, the weight of this one will act downward, while the force produced by the surface of the table is the normal reaction force. So weight of this one will act downward, force produced perpendicularly upward is the normal reaction force. So it is an upward force. E now, which is upthrust force. This is force produced on the first surface of any liquid on any solid object immersed in such liquid. That is, force produced, the upward force produced by the surface of liquid on any immersed object in the solid. Let's write upward force produced by the surface of liquid on any solid object immersed in the liquid. This upward force produced by the surface of liquid on any solid object immersed in the liquid is what meant by upthrust force. Next one, which is F or number 6, is frictional force. Frictional force. When you say frictional force, it's the force that opposes motion of the relative motion of two solid objects in contact. When two solid objects are in contact, the force that opposes their motion, their relative motion, is what we call frictional force. The force that opposes the relative motion of two solid objects in contact. Or that opposes the relative motion of two solid objects in contact. That's frictional force. For instance, let's say this surface of a table. You roll, let's say, a ball on this table. The applied force will act like this. The frictional force will act like this. So this is the applied force. Applied force. Frictional force will act in opposite direction. So as the ball is rolling on this smooth or unsmooth horizontal surface, the frictional force will be in opposite direction, dragging it back, gradually the ball will come to rest due to the effect of this frictional force. And if there is no effect of this frictional force, it's supposed to move like that without any hindrance. But due to the effect of frictional force, the frictional force will be dragging it back gradually until it finally comes to rest. That's why we define it as the force that opposes the relative motion of two solid objects in contact. Now, these are the possible examples under contact or mechanical force. As we have mentioned, we mentioned 6 now. Now let's now go to non-contact force. That is number 2. Non-contact, or we call it field force. When I say non-contact or field force, this is the first experience, within the field of the two material involved. The first experience within the field of the two material involved. That is, under this one, that is why we call it non-contact. The two solid material is not necessary to touch each other, but the force will be experienced within their field. Example under this one, examples of non-contact force. We have 1, electric field force, and this is the force experienced between the surges of an electric field. Force experience between two surges. It can be either two positive surges, can be either between two positive surges, or one positive and one negative charges. Or it can be both negative charges. So the first experience is what we call electric field force. The two positive charges or two negative charges need not to come together and touch each other before the first experience. It will be experienced within their field. This time, let's say this is positive charge and this is another positive charge. So when you bring them together, let's say this is the region of this one and this is the region of this one. That is the region of the electric field. So immediately when this plate reach this place, then the force will be experienced. Although this is the surge, this is another surge. Well, this is the region of their field. So when this point this region reach this place, then the force will be experienced. It's not necessary the two charges touches each other. And the force that we experience here, since this is two positive charges, we call it repulsive force. So in between these two, there will be repulsive force. So repulsive force will occur. Repulsive force, they will repel each other. But if it is positive, negative, then attractive force will occur. And the second one, under non-contact force, is magnetic field force. B, magnetic field force. And when you say magnetic field force, this is the force experienced between two magnets. The force experienced within the field of two magnets. That is force experience between the field of two magnets. In the field of two magnets. Magnets, we have two poles, north and south pole. So when you have a magnet, let's say this is north pole magnet and is bring to south pole magnet. Now, since this one is north, this one is south. According to what we draw on that one, let's say this is the region of the field of this one, and you have this one as south. So this is its own region, means south. So this is the region. Mainly when this place touch this place, then the force will be experienced. And since this one is north and south, what we call here is what we call the attractive force. It will run from north to south. So the attractive force will occur here, attractive force will occur here because this is north south. If it is north north, then like this one, repulsive force will occur. So the force experienced between the field of two magnets is what we call magnetic field. I've demonstrated this one as north and south pole now. This is north pole, this is south pole. And the field of this one, the region of it is this way, and the region of this one is this way. When these plates touch each other, then what we call this attractive force. But if it is not north, repulsive will occur. That is for magnetic field force. The third one, which is under non-contact force, is gravitational field force. Gravitational field force. Gravitational field force. And when you say gravitational field force, this is the force that the Earth exerts on a unit mass on the Earth's surface. The force that the Earth used to attract the unit mass toward itself is what meant by gravitational field force. That is the force of attraction of the Earth on a unit mass on the Earth's surface. The force of attraction of the Earth on a unit mass on the Earth's surface is what meant by gravitational field force. That is why If you throw anything up due to gravitational field force, then the gravitational field force will draw it down. It will come back again. Anything that go up, we believe that it will definitely come down due to gravitational field force. So these are the possible examples of non-contact force. We've mentioned three. One, electric field force. Two, magnetic field force. Three, gravitational field force. And under contact force, we mentioned six. And the question may ask that mention two main types of force. Don't forget, they are non-contact force and contact force. And I told you another name for contact force is what? Mechanical force. Another name for non-contact force is field force. But apart from that, if the question now say, instead of mention the two main types of force, the question now say, mention 5 types of force. It means you mention example under contact force, you mention any example under non-contact force. That is why we said those are the two major types, contact and non-contact. But example under it are also type of force. Thank you. Now, in our next lesson, we are going to continue with frictional force. And we are going to take it as a major topic which will form the basis of our discussion. And don't forget, as I said earlier, to join this lesson under this platform, please try to like, share, subscribe, so that when I post a new video like this, you'll be able to get the notification. Thank you.